Hello and welcome to SynthGen update number 3, take 1, about this tool I wrote called TDAR. I've been talking about it in my daily updates and nobody knows what the heck I'm talking about, therefore here's a video. But first, here's the farm update. Is this chicken was kind of sick and understandably,
because
filled her water
the
chicken coop was very cold
dish
and all the
with
water was
sawdust.
full of
Again.
chicken poop.
Chicken, you're
Not
terrible.
a good place for a sick chicken, so we
You look
brought
like
her
you're
in.
healthy though.
Yeah, she's a good chicken, except that she keeps filling her
Gesundheit.
water bowl with wood chips, and then we have to throw out the wet wood chips and give her new water. Okay, so on with the show. I'm going to open a REPL here, a Deno REPL, and paste some stuff into it. Okay, so I'm going to import some things, paste in this stuff. Various tools that are going to make this a little easier. Okay, so TDAR, let's see, what can I say about TDAR? TDAR stands for TOGoS' Deno Active Resolver. What the heck is an active resolver, you might ask? Well, there's this idea that of an active URI, which is basically a functional expression crammed into a URI. And this idea came from these netkernel guys. Their website is horrible. Like, what is it even about? Like, what is it really about? It gives some hints. It's like memoization and stuff. Like, you can do a calculation, it'll remember the result. But yeah, basically you have these URIs that encode a functional expression, and their system just resolves them. So I've kind of taken this idea and made my own implementation, which I'm sure is like incompatible with theirs in all sorts of ways, because there's a lot of options for how you interpret what they wrote. Let's get started here, though. I'll evaluate some expressions, or create some expressions. So I have this literal value expression function that I wrote. If I call it, this is the representation in Deno, which happens to be valid JSON, of an expression that returns the string hello world. So this long name, it's a long name, so it's unambiguous. Also, all of these things are easily encodable as RDF, which uses long names that look like URIs for types and attributes. So there we go. That's hello world. That's the literal string hello world as an expression. What else can we do? We could do not just strings, but numbers. Note that it uses a different type, even though, in the JSON representation you could distinguish, but there might be other representations like the RDF XML one where you wouldn't be able to tell from what's in the literal value property. It might be ambiguous whether you intend for that to be a number or a string, and so I have different types for those two things. These are all defined by this project TOGVM. I've been kind of building on that for years. A lot of stuff I did at Earth IT used this same schema. The VCV rack plugin generator that I wrote last year that's part of the same project also uses the same scheme. All right, so anyway, that's pretty boring. What's something a little more interesting? Function calls. So if we do, let's see, TDU, I think I imported a module called TDU. It's got some stuff in it. This is just a helper thing, helper module to make func call. So we say what's the function we want to use. is the first argument to funcall function ref. So we take we want to use this concatenation function, so we pass its name, that long thing, as the first argument to funcall, and then the rest of the arguments to funcall are each an argument list. And the reason I do that is because all the arguments are named in this system, because when you make an active URI, because of the format of the URI, every argument has to be named. There's no just positional arguments. And so in this case, it's like, what do you call it? It's the things you want to concatenate. So it's just item. But there's multiple items, which means you have multiple values for that argument, and you can't represent that in a single JSON object. Therefore, multiple objects. So what do we want to do? We want to say, like, hello as one argument, and then world, and this function call expression construction function is designed to make this easy. So if you pass it a literal string, it assumes you mean that literal string. So here we go. We made an expression that it represents the concatenation of these two things, hello and world. All well and good. There's also expressions to represent files. So if we make a file path expression, that's what it looks like. And you say, that doesn't look like file path, that looks like it says variable. Well, the way I'm using this, and the way I've used this expression schema in the past too, I'll use the variable expression not just for variables, but anything that has some kind of string name. And so when we say a variable expression have a variable name, if this looks like a URI, it's a URI. And so this variable represents this file, because this is a file URI. And you could even do, let's see, file path expression. I think I can do like a web URL. Now that's not, we're kind of abusing the file path expression function here, but the result is, oh yeah, the result is not valid at all, because now it's saying file and then this URL, which is not what we wanted. We just wanted the URL. So don't do that. Is there a URI to expression? Yeah. So in this case, what I really should have said was URI to expression. And there we go. Now we got an expression that represents this web resource. Okay, so we can represent. We have this, you know, this way of encoding these functional expressions as objects. So that's great, but you know, let's do something interesting with it. Literal string expressions, concatenation expression. I'm looking at my script here, trying to pick out the next thing. Yeah, showed the net kernel web page. That was boring. Okay, so the next step is to resolve expressions. So there's this resolver object. It's got a lot of different options in it, like where do you want to cache results, things like that. This function I wrote takes a bunch of options from the environment, which I set before I started the script, and creates this resolver object, which then you can just use. So let's stick a let's create a literal hello world. So there we go. Is the same thing we made earlier with a concat. Now it's a literal string. So if we tell resolver to resolve it, literal hello world, and this returns a promise, so we got to await it. Well, that didn't do much, did it? Because a literal string, for purposes of resolving these expressions, it's already resolved. That's as simple as it gets. You gave it a literal, you get a literal back. Okay, not super interesting. Same thing if we give it await that, da 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 da, you get that same expression back. So let's do something a little more interesting. Make one of these file path expressions. There's the expression. Now what's this going to do when we resolve it? Now I'll tell you what it's going to do is it's actually going to take the contents of that file, store it in an internal repository, and give us back a variable expression that references that content by its hash, because that's considered the canonical normalized form of the result of this expression. So let's see, await resolver.resolve hello world.text expression. Ta-da! And there you go. Now additionally, the resolver can give you resolver.getFile. Let's take the result of this and put it in a variable. Const. Yeah, I already wrote this, so I'll just copy what I wrote before. So there's the variable that contains the resolved expression. Resolver has this handy function getFile. So if there is already a file somewhere on the file system that it knows about that contains that result, it'll just return the path to that file. Otherwise, this getFile function will create a temporary file and write that result into it, and it keeps a list of temporary files internally. So if you want to go and clean it up later, you can. Well, we got to await it, of course, otherwise can't see the result. So because this is a bit print, it has the SHA1, the tiger tree hash. Anytime you get one of those back, it means that the resolver has stored this file into an internal repository, which I had an environment variable that told it to put it here. And then files are named based on the SHA1. This is a system I've been using for a decade and a half now also. So it's nice to not have to reinvent that. So now you have this file, and if you wanted to, you could go and verify. You could say await Deno.read text file. So there's just a Deno function here. It's not going through any of my stuff. This just shows that, yep, the content of the file is indeed hello world, which we originally, told it up here. Came an expression, got resolved, got put in a file. Actually, no, in this case, I wrote this file ahead of time, but same difference. So the system can deal with files. That's what I'm showing here. Okay, now for some perhaps more interesting stuff. Let's give ourselves some blank lines. Let's do a concatenation. Let's see, a concat expression 2. I don't have concat expression 2 defined yet, so let's define that. Where is it? There's a concatenation expression. You notice this one has, give it 2 items. One is that hello world.text, and the other one is a literal string. As before, this funcall translates that into a literal string. So let's look at it. Let's look at the expression as a whole. Okay, so this is a function application expression that will apply the concatenate function to these arguments. This one called item, which is the variable, quote-unquote variable, which says use the thing called file colon hello world.text, and the other one is a literal string, hello, also goodbye. Okay, so now we have that expression. We can evaluation function application. We can resolve it like so. So the result of concatenating these things, guess what it's going to look like? It's going to be, because it created some data, it has to store it somewhere in order to cache it, so it's going to be another bit print. There we go. By the way, this is the tiger tree hash requires the tiger hash function, which I added to the Deno standard library specifically so I could do all this stuff, and they released version 0.119 thanks to that. It was actually very simple because I just used the tiger crate from Rust, because everything, all these Deno extensions are written in Rust, and then they compile them to WebAssembly, so yeah. It sounds very complicated, but getting it to work was actually pretty easy. So what else can this resolver do? We have this result. We could, if we want, we can say get string. Can we pass it a URI? I don't think we can. I think I could make it so that you can pass a URI, but no, it wants an expression object. So concat results. So we say await resolver.getString. This getString expects a expression object, and actually it expects not just any old expression, but one that's already been resolved. I'm kind of thinking that's dumb. Because it's the same resolver object, it should know how to resolve things. So you should be able to pass it any old expression. For now, you have to resolve it separately and then pass it to getString. Easy to fix. I'll probably do that later tonight. So we got the string, and there we go. It's those two things concatenated together, the contents of hello world.txt and also goodbye. Very interesting. By which I mean you're probably bored to death, and I'm surprised that you got this far into the video. Oh, one other thing we can do, we can say check out file. Check out file, and this function actually does take any old expression. It doesn't have to be the already resolved one. Hello world and goodbye.txt. And it returns a promise, a void. Alright, so if we do await deno.read text file, partition, there we go. There's our stuff. So you can create these expressions that are complicated things, much more complicated than just concatenations of strings, and pass those expressions to the resolver, and it can give you a string back, or it can check it out as a file. There's a couple other things it can do. One of the things it can do, it can return a blob, but it's not a JavaScript blob. It's my own blob-like thing, because I didn't like how complicated JavaScript blobs were, but that's a topic for another day. Okay, here's something we can do. SVG logos. Like I said, you can get any old URI. So if we look at this expression, it's a URI expression. It hasn't actually done any downloading yet, but it knows how to. Resolver.resolve the SVG logo SVG expression. Might take a minute because SVG logo result, let's say SVG, because we're specifically getting the SVG itself, not a picture of it. This might take a second because it has to actually go download it. It just uses fetch. Any URI that Resolver doesn't specifically know about, it doesn't know about HTTPS, it just passes to the fetch function. And hopefully fetch knows about it. And if you pass it something fetch doesn't, then it'll crash, you know. Then you'll get an error. You'll say, I don't know how to get that. For example, if you say resolver.resolve. Now resolve actually does take either an expression object or a URI, but you could say hxxp, because, you know, this is like the C++ version of HTTP. To, you know, whatever. Await that. What do you get back? Oh, you get an error. Nobody knows what hxxp means. So, yeah. All well and good. So, anyway, what's in here? What is this? Oh, look, it stored it. So we could get that file. We could get the path to that file and like look at it and stuff. Actually, yeah, let's do that. Deno, just to make sure that it's the right thing. Deno, or not Deno. Await resolver.getFile. SVG logo SVG result, and it'll tell us where that file is stored. It's right here, and then let's go over to ye old web browser and type in. Hopefully Firefox knows about backslashes. Yeah, it figured it out. So there we go. It doesn't know it's an SVG because there's no file extension, but there we go. The file has been downloaded. It exists. Good stuff. Close that tab. Back to the terminal. Okay, so the next thing to do, well, why don't we go over to Reason? So this is my SGP20R Reason Rack plugin that I made a month ago or something. All this infrastructure work takes forever. But this knob is, it's what they call a film strip or an animation. Yeah, I think they call it a film strip. The VST SDK maybe calls it an animation. Same idea though, an exact same technique to make it. In this case I made an SVG of this knob, along with everything else in here. All these graphics are based on SVG, except for this thing, but whatever. It's all SVG just because that made it relatively easy to generate things. And then I had to rasterize them. So I used Batik, which is this Apache Java program that I think used to be actually the reference SVG rendering tool. Oh, there's a kitty meowing. What was I talking about? SVG rendering tool. Yeah, Batik. So it has to run Batik. And the problem I was having was that there were all these different files that could influence the result of what this looks like, or what these look like. Especially if you look at the back, because there's actually, it's hard to see because it's very dark, but there's some bitmap graphics over here. And this back panel, the SVG of it, referenced those graphics. And then that whole thing got passed through Batik, which then created a PNG, which includes both this green part and the sides. They're not transparent. If you give it transparent, the result is not very good. You kind of have to copy these graphics and mess with them to make everything look right. And there's that little line there. That doesn't look quite right. Anyway, so there's more than one input file. It's not just the SVG, it's also these other files that influence what the output looks like. And to be safe, my build system was just anytime any of those were updated, or sometimes other files, because it didn't actually know what all was in there. Anytime anything was updated, it had to rerun the rendering. So that, that took extra time, extra CPU that I didn't want to spend. And that's kind of the reason that I started this whole TDAR thing, was because I'm like, well, if I can just go read all those input files, calculate their hashes, which is quicker than running Batik, and then build this expression that represents the result, and if that input expression is identical to something I've done before, I can just use the same result. I don't need to calculate it again. That's the whole point of all this. Now, this TDAR system, there's more that it can do. Like you can read directly from URLs and stuff like that. But this was the basis. Wanting to make this knob in a slightly more efficient way was the reason for all of this. All right, back to the terminal. What do I need to talk about next? Okay, so yeah. So I got the SVG logo. Was that this? Yeah, so this expression represents the SVG logo now. SVG logo, SVG result. So what we want to do next is rasterize it. Okay, so I'm going to set some constants here. Paste these in. I'm pasting this stuff from another window, so if you're wondering why is he going away, and oh, SVG rasterization expression is not defined. Oh, right, I need to import another library. Okay, so this is just a helper library, so I don't have to type as much stuff. So I run this function to create a rasterization expression. So this is the expression that represents taking that SVG file and running it through BATIC. This one's pretty simple because the input is just a single file. Well, in this case, it actually uses a web URL. And then the width and height are literals. And that resolver that I created long ago, this object, resolver. Oh, geez. Well, it knows about a function rasterize using BATIC, just because what I call the demo resolver knows about that, and it knows about concatenation. Why does it know those two things? So that I can do demos, like this one. Anyway. So, yeah, rasterize that SVG. That was, oh geez, wherever it went. Rasterize that SVG. That's this expression object. Now, we haven't actually done the calculation yet. In order to do that, we can say, for example, oops, what did I just do? I hit the wrong button and opened a window. Okay, let's try this again. Copy this. Okay, into the terminal. Now that file actually already exists, so let's SVG logo take one. Might take a second because first it's got to download the thing and then it's got to run it through BATIC. So, well, promise, pending. Actually, it doesn't have to run it through BATIC because I did this earlier. And it cached the result, and the input is exactly the same. It did have to download the URL again, because it doesn't know whether that's changed or not. But let's see. So we'll go back to Firefox and just look at the file. There's that back panel, SVG logo. Okay, so this is the one I did it earlier, but we'll type in take one here. Sarah is trying to intimidate a cat away from a cake. Okay, so here's the one we just generated. So as you can see, it worked. All we had to do was say check out file, give it that expression, the file we wanted to stick the result in, and this expression can be as complicated as we want. This could have all sorts of, nested function calls and stuff. So to demonstrate something slightly more complicated, let's see. I'm actually gonna I'm gonna delete a file because I forgot to delete it earlier. P0011 2022 TDAR demo. Let's delete this thing called backpanel.png. That was this. Okay, file not found. Sorry, Firefox. File not found. There's no back panel. What are you talking about? We have to generate it. And I will use one of my helper functions again. Back panel SVG file path. So that's where we keep the SVG of the back panel that you saw earlier in Reason. And we will make a construct an expression to rasterize it. And now look at this expression. It's a little bit, there's more to it than that other one. So the reason there's more to it is because that SVG file references a bunch of other graphics. Argument expressions, so we got the width and the height. Yeah, great. And then instead of just having an input, we actually give it an input file name, and then a whole bunch of files. Each one of the files arguments the name of the argument starts with files / anything that starts with files / the BATIC rasterizer takes to mean I'm going to ask you to rasterize an SVG file, but in order to do that, you need to have all these other files available. So what it ends up doing then is it takes this file and this file, which it gets from these sources, the value of these arguments. It says where to get it. Although Batik doesn't actually see this. Which I can't really show that in a... I can show that because I can copy this expression. Anyway, so there's all these different files, including the back.svg, which is one of the file arguments, and then we also tell it as the input file name, use back.svg, which we will pass in, along with all these other graphics. So, like I just said, we have some input file. So we have that. The Batik function does not ever see this. Well, instead, when the resolver applies a function, it first applies all the arguments. I mean, it resolves them. Resolver, resolver.resolve some input file expression. It's the one with the blackness and stuff. Resolver, some input. Don't know how to resolve expression, class ref. Well, that's interesting. Why does it not know how to... Oh, because that's the entire argument. Yeah, okay, sorry. The named value only makes sense within the context of a function expression. You can't resolve it on its own. I mean, I guess you could. I could make it so you do, and it just gives you a named value back. But, I don't know. There's not much point to that. Anyway, so if I pass in this argument expression to resolve, it gives us the resolved version of that argument value, and this is what actually gets passed to Batik. And the Batik function then goes back to the resolver. It creates a temporary directory somewhere. It goes back to the resolver, and then for each argument it checks it out to a place matching the path given here. So some temporary directory / all this stuff. It checks out all the files, and then it runs Batik using using the jar file, which is configured with an environment variable. If that environment variable was not set, we'd get an error when we tried to rasterize. So let's see, have I... Oh, no, I haven't actually resolved the thing yet. So back panel rasterization expression. So that's this, that big old expression with all those argument expressions that are all the different files and width and height and path to the SVG. So the last step here, of course, is to say resolver.checkout file, resolver.checkout file, back panel rasterization expression, and then we'll call it back panel take one, just to keep with our naming scheme here. Crossing my fingers that this works. I think it worked. Of course, I'm a little bit cheating here. The reason it was so quick was because I did all this earlier and I didn't clear the cache. So let's just quit out of here. Look at the directory. Back panel take one. And it's actually, it didn't even have to copy the file because it does hard links from the repository. Why copy when you can hard link, huh? So we can go back to Firefox, and this file doesn't exist because I gave it a new name. Take one. Ta-da! And as you can see, it's got this detail over here, the main part in the middle, which is just pure SVG. So it correctly referenced that file. So yeah, that's what I've been doing for the past...
Just getting a video of you existing because you're so precious.
Jeez. Yeah. A lot of time. But it does a job. I think it works pretty well, and hopefully it's also useful for generating graphics for George's project, or basically any other time we have to generate graphics. They don't have to be from SVGs either, or generating other resources, sounds, graphics. Anytime we need to like generate resources from other resources and we want to cache the result, right? That's the whole. That's the appeal of this, as the 1060 guys. All the stuff they say in here, you know, what's this? This picture tells you nothing. This is a terrible website, but it's a cool idea. They do consulting. Maybe I should do consulting. Like somebody's going to use TDAR. Oh, and here's the guys who invented NetKernel. Very cool dudes. They have beards. Yeah. Very overused quote. Yeah. Oh, yeah. Did I mention that I'm using OBS to make this video? It works way better than that trialware stuff I was trying to use earlier. OBS is working great. Big approval. I approve of OBS, and I just had to choco install OBS Studio to get it. Very easy. Yep. I think that's all I got. So, there's our chicken.
Hi.
Good night, everybody.